8.1 Sequence and Summation Notation. We're going to write the first four terms of the sequence whose general term is given. So for instance, if we do a to the 1 here, then basically everywhere we see an n here, we're going to plug in whatever subscript we put there. So this is going to be 3 times 1 plus 2. 3 times 1 is 3. 3 plus 2 is 5. And then with the first four terms, then we have to do it again. A, 2. So now where we see an n, we plug in a 2. And then add 2 at the end. 3 times 2 is 6. 6 plus 2 is 8. Then we have the third term, which is 3. So wherever we have a n, we are going to put a 3. So we have 3 times 3 plus 2. 3 times 3 is 9. 9 plus 2 is 11. Next we have an a to the 4th power. Or not a to the 4th power, but the fourth one in the sequence. So we're going to, everywhere we see an n, now we're going to plug in a 4. And add 2. Let me say 3 times 4 is 12. 12 plus 2 is 14. Next we have this one. Again, same kind of pattern. So wherever we see an n, we plug in a 1. So that first one in this case is going to be a 1. 4 to the nth power, 4 to the first power is 4. Next one is for second one of the sequence. So now we're going to have 4 to the second power. 4 times 4 is 16. And next we're going to have the third one in the sequence. 4 to the third power is equal to 64. Then we're going to have a fourth one in the sequence. 4 to the 4th power is 256. Okay. And then we have the next one in the sequence over here. So this is the first one is going to be, I just go through this entire thing and I replace. So for instance, n plus 1 is going to be a 1 plus 1. And that's multiplied by n plus 2, which is just 1 plus 2. Do simplification. So we have negative 1 to the second power, because 1 plus 1 is 2. And 1 plus 3 is 3. Order of operation, negative 1 squared is a positive 1. And that is going to be multiplied by 3. 1 times 3 is 3. That's the first one. The second one, same kind of pattern. Everywhere we see an n, we're going to replace it with a 2. Negative 1, 2 plus 1, 2 plus 2. So you end up with negative 1 to the positive third power, because 2 plus 1 is 3, and 2 plus 2 is 4. Negative 1 to the third power is negative 1, because a negative times a negative times a negative is a negative 1. And we keep the 4. Negative 1 times 4 is negative 4. Next, we move on to the third one. Again, we go through the entire sequence, and we're going to replace all the n's with 3 now. So 3 plus 1 and 3 plus 2. Negative 1 is now being brought to the 3 plus 1 power, which is a 4, and 3 plus 2 is 5. Negative 1 to the positive 4th power is a positive 1 times 5, which gives us a 5. And we're now on the 4th one in the sequence, which is negative 1 to the now 4 plus 1 power, and then 4 plus 2 within the parentheses. So I just replaced all of the n's with the 4th, with the 4. Okay, so we have negative 1 to the 4 plus 1 or 5th power, and the 4 plus 2 is 6. Negative 1 to the 5th power is a negative 1, because a negative to an odd power is a negative. And that's negative 1 is going to be multiplied by a 6, which gives me a negative 6. So we go down here. Now we're going to deal with a recursive sequence. Recursive sequences are a little bit different in that, let's say I'm trying to find, well, the first one they give it to you, right? So they give you the first one of the sequence. So we know A1 is 4. Now, what happens if I try to find the second one of the sequence? In the sequence, it actually has an, right? Okay. But it's an minus 1. So if I'm trying to find the second one here, again, I'm going to plug the 2 in wherever I see the n. So I'll add this extra step. You really don't probably need to write this, but I'll add it. So it's 2 minus 1 plus 9. Now what that means is A2 is equal to 2 minus 1, 1, right? So 2 minus 1 plus 9. And what is A1? Well, A1 is 4. So it's 4 plus 9. And 4 plus 9 is 13. Okay, we do the next one in the sequence. Now we're looking for A3. And that's going to give me 3 minus 1 plus 9. All right, so we say a third one of the sequence is going to be 3 minus 1, which is the second one, plus 9. Well, that right there is 13, right? The second A, right, in the sequence is going to be 13. So we're just going to go and we're going to replace it or substitute in a 13. And that's plus 9. 13 plus 9 is 22. Okay, then we move on to the next one. So now we're looking for the fourth one, which means we're going to have a to the 4 minus 1, and then we add 9. Now, a to the 4 minus 1 is really 3. And what is the third one? Oh, well, it's 22. So we substituted 22, and then we add 9. And then 9 plus 22 is a 31. And if we want to do this one more time, for instance, it did say first 4 terms in the sequence. Technically, we already did it because the first one was a 4. They gave it to us, but we can just do another one just to make sure we get the concept. So now we have a 5 minus 1 plus 9. Now, 5 minus 1 is a 4, and then we say plus 9. Well, what is the fourth one in the sequence? Well, it's this one right here, right? It is a 31. So wherever we see an 8 at the fourth one in the sequence, we're actually just going to substitute in the 31, and then we are going to add 9. So 31 plus 9 is a 40. Now the next one actually doesn't have a recursive. You're not plugging anything different. So just wherever you see the in here, I'm going to plug this in here and here and then simplify. Okay, so let's try the first one. So the first one might be something like a 1, and then we're saying 1 cubed over 1 factorial. Well, 1 cubed is 1 times 1 times 1, which is just 1. And 1 factorial is just a 1. 1 divided by 1 is 1. Okay, first one is pretty easy. Let's try the second one. Second one is 2 to the third power over 2 factorial. 2 times 2 times 2 is 8, and 2 factorial is 2 times 1, which is just a 2. 8 divided by 2 is a 4. So now we try the next one. Now in this case, we're actually going to plug in a 3 cubed over 3 factorial. 3 times 3 is 9, times 3 is 27. And 3 factorial is 3 times 2 times 1. So you end up with 27 over 3 times 2 is 6, 6 times 1 is 6. Now we can reduce this fraction. We can divide both of these by 3, or you could just cancel the 3 out at an earlier point. But 27 divided by 3 is a 9, and 6 divided by 3 is a 2. So you end up with 9 halves there. When we evaluate the factored expressions, so this is a trick we used before. So I'm going to break down the larger factorial, the 18 factorial, until it matches the other factorial, the smaller one over here, the 16. So first it's going to be 18 factorial is 18 times 17 times 16 factorial, and now that matches the bottom. So you end up with a 16 factorial in the numerator and the denominator. They cancel out, which gives you 18 times 17. It gives us 306. Next one is 15 factorial over 2 factorial times 13 factorial. So we're going to break the 15 down until it matches the 13 factorial in the bottom. So we have 15 times 14 times 13 factorial all over 2 factorial times 13 factorial. Now the 13 factorials cancel out, and that leaves me 15 times 14. And we're going to put that over 2 factorial, which is really 2 times 1. We can even cancel this 2 out with the 14 and get a 7, and that gives me 15 times 7, which is 105.